This recording is to execute or complete the Unit 5 sample work, vocabulary for Unit 5 on transformations. So let's get into it. First word from Lesson 1, first word is transformation. Okay, a transformation is a rule that changes a pre-image into an image. For example, this translation slides the triangle on the left to the triangle on the right. That's a type of transformation. Image. Image. This is after a transformation. Okay, and if you're going to label another, use a diagram more than once, label it. This is the image. Pre-image. The pre-image is before a transformation. This is the pre-image. Okay. Composition of transformations. Composition of transformations. Okay. More than one transformation. For example, we might reflect and slide. Reflect and slide. This particular one is called a glide reflection because it reflects and slides, or slides and then reflects. Composition. Rigid transformation. Okay, it keeps all lengths and angles the same. It's also called anisometry. Okay. So a translation is a rigid transformation because the triangles remain the same shape and size. All right, that's lesson 1. All right, let's go to lesson 2. Lesson 2 is on reflections. Keywords, reflection. I call it a flip across a line. So this triangle reflected across this line looks like this with a flip. Line of reflection. That's the line flipped across. Okay, as in this vertical line is called the line of reflection. Okay, that's it for lesson 2. Lesson 3 on rotations. Okay, let's get some new space up here. Rotation. To spin around a stationary point. That means a point that doesn't move. Example, this triangle rotated around this point. Looks like this. That would be a 90-degree counterclockwise rotation. Center of rotation. Center of rotation. The point spun around. In my drawing, this is the center of rotation. Angle of rotation. The measure of how much spin in this case, this was a 90-degree clockwise rotation. That's called the angle of rotation. Center of a regular polygon. The point in a regular polygon about which you may spin and still be congruent. Okay, example, this square, the center of the polygon, if you rotate 90 degrees, the square will match itself. So that's the center of the regular polygon, in this case a square. Okay, that's it for lesson 3. Lesson 4. Lesson 4 is about reflection. Reflection. So let's start with reflection. Reflection. I think we did reflection, didn't we? Yeah, we did reflection. So the word is symmetry. Matching by reflection or rotation. A butterfly has symmetry. In this case, it has what we call line symmetry, because the left side is the same as the right side. Line symmetry. Matching. Across a line. Okay. The butterfly has line symmetry. Point symmetry, or rotational symmetry, actually. Rotational symmetry. Matching. By rotation. A yin-yang symbol has rotational symmetry because if you spin it 180 degrees, it matches itself. Top matches the bottom. Rotational symmetry. Point of symmetry. That's the center point rotated around. In this case, if I put a pin in the center, that's the point of symmetry. All right, line of symmetry, line symmetry. I'm not going to do line of symmetry. Actually, we'll do line of symmetry just right there. I'm not going to do it separate from line symmetry. All right, so that's it in unit lesson 4. Lesson 5, dilations. Dilation. Let's go ahead and reposition here. All right. So dilation is to grow or shrink. So this small triangle grows by a scale factor of 2 to become this triangle. Everything's twice as big. Center of dilation. That's our stationary point. Okay, so for example, if the center of dilation is right here, and I double the dimensions, everything moves twice as far away. So -1, -1 becomes -2, -2. 1, 2 becomes 2, 4. Okay, and 3 becomes 6. Okay, there we go. And so this is the center of dilation. Everything's moving either away or towards that point. Okay, so we've done dilation, center of dilation, enlargement, means to get bigger. Both of these are enlargements. Okay, reduction. Get smaller. Okay, so I can halve the distance, right? Instead of 1, 2, we can do half and 1. Instead of 3, we can do 1.5. Instead of -1, -1, -1/2, -1/2. The yellow shape is a reduction. As opposed to the orange, which is an enlargement. Okay, and the most critical one here is scale factor. That's the new size divided by the old size. Okay, in this case, the orange scale factor is 2. The yellow scale factor is 1/2. Scale factors greater than 1 are enlargements. Scale factors less than 1 are reductions. Okay. All right, that's it for scale factor and dilations. Compositions of isometries. I think there's only one more word. Nope, there's 2. I've actually already defined this word. Rigid or isometry. It's a rigid transformation. Dilation is not rigid because things grow and shrink. So a translation is an isometry because the image is congruent to the pre-image. And last word, glide reflection, which I've actually already mentioned. A slide parallel to a line and a flip across the line. And that can be in either order, actually. But let's say we've got a triangle, and here's the line of reflection. We'll translate parallel to the line, and then we will flip over the line. And it could be a flip followed by a slide. They'll end up in the same place. That's a glide reflection. Okay, that's lesson 6. Lesson 7 was the portfolio. Lesson 8 was the review. So that's it. Das is it. Golly gee for sure. Don't you know, you betcha.